Welcome to Study Loop.
So here we're asked if a positron and electron collide to be converted into energy in the form of two photons, what are the wavelengths of those two photons if they're equivalent? So the first thing that we need to do for this problem is determine how much energy the positron and the electron can produce. We're going to do that using the E equal mc squared equation. So the total mass of a positron and an electron is 0.011 AMU. This equates to 1.1 times 10 to the negative 6 kilograms. When plugged into our equation, I'm going to multiply that by the speed of light, 2.99 times 10 to the 8th meters per second, and that'll be squared. And the last thing I'm going to do for this problem is normalize all of this to two photons, because we know the two photons are going to be produced. So what we can tell is the amount of energy produced in these two photons, or per photon, is 4.917 times 10 to the 10th joules per mole of photons. So the only other thing that we need to do at this point is now figure out what the energy of these photons will be, or the wavelength of these photons will be. So we've done this in terms of moles of photon because the way the balanced equation works out. So if we adapt this equation now, this modified version of Planck's equation, we can solve this for wavelength. We find that wavelength is equal to Planck's constant, 6.626 times 10 to the negative 34th, multiplied by the speed of light, again 2.99 times 10 to the 8th, and multiplied by Avogadro's number, 6.022 times 10 to the 23rd. And we will divide all of that by the energy that we just solved for, 4.917 times 10 to the 10th. So to complete this setup, this portion is the portion that's listed in our equation, and we're multiplying by Avogadro's number because, again, the energy that we solved was in terms of moles of photons. We just want to consider this in terms of an individual photon. So the wavelength that comes out of this is 2.42 times 10 to the negative 12th meters. And that's going to be the wavelength of each photon that comes out of this collision of a positron and an electron.